At range, a Tiger I could destroy an Allied tank before its crew could answer. Its 88mm gun and thick frontal armor made that fear rational. Yet the first 4 Tigers in combat produced a different warning. 3 broke down on their first day near Leningrad. Germany's battlefield hammer had arrived with a recovery problem. How could a tank so dangerous fail to deliver the operational advantage Germany needed? The answer begins on August 29, 1942, near Maga, southeast of Leningrad, not in a design office. At Maga, the clue became a number. 4 Tigers deployed, 3 disabled on the first use. 2 transmissions failed. After mud packed the interleaved wheels, a 3rd tank lost its engine. The terrain was forested, wet, and badly drained, the opposite of the clean proving ground a new heavy tank needed. Major Richard Merker had warned that 4 56-ton vehicles would achieve little there. He was overruled. Once the Tigers stopped, firepower became irrelevant. Each recovery required 3 SDKFZ-9 FIMO half-tracks working together. Replacement parts were flown from Germany. The tank's first battle had already exposed a system extending far beyond 5 crewmen. 3 weeks later, all 4 Tigers broke down or bogged during their second use. 1 could not be recovered. That debut did not prove the Tiger useless. It proved that tactical power had to survive contact with terrain and logistics. When a Tiger was functioning and well-positioned, the threat facing an Allied crew was immediate and thoroughly physical. The Tiger's advantage was not folklore. Allied examiners measured a 4.02-inch frontal plate, counted 92 88mm rounds, and judged the protection very good, strong enough that they called for a 17-pounder class weapon for effective armor-piercing attack. Its KWK-36 combined high velocity with good optics, giving trained crews an excellent chance to fire first at range. The 5-man layout also separated command, loading, and gunnery tasks, helping an experienced crew find, engage, and correct quickly. For Sherman and Churchill crews in early encounters, the problem was not mythology. Their usual weapons could struggle against the frontal aspect. A Tiger could exploit open sight lines, hull-down cover, and deliberate positioning, destroying vehicles before they reached a favorable answer. That advantage was local, but local advantages kill people. A penetrated tank could mean fire, blast, and seconds to escape. The Tiger therefore changed behavior. Crews sought flanks, heavier guns, artillery support, smoke, or routes that denied a clean long-range duel. But strong armor was never the same as perfect armor. Tracks, turret ring areas, sides, and circumstances still mattered. Allied adaptation was cumulative. Better anti-tank guns, field artillery, mines, maneuver, and the simple discipline of avoiding the Tiger's best shot. Fear was rational. Invincibility was not. The question now moves from what the Tiger could hit to what could move it. Allied intelligence estimated the Tiger between 50 and 60 tons. Every extra ton protected the crew, but entered another calculation: ground pressure, bridge capacity, rail loading, towing force, and mechanical stress all traveled with the armor into every operation. A knocked-out Tiger beside the road was not only a lost gun, it was a recovery mission under enemy observation. The interleaved wheels spread the load and supported a stable firing platform, but mud, ice, and damage complicated access. Wartime examiners even noted weak retaining rings on track pins and uncertainty about cross-country performance in their captured examples. For rail movement, outer wheels were removed and narrower transport tracks fitted. Then the process had to be reversed. That was engineering work before combat, and more work again whenever a disabled vehicle had to leave the battlefield. A bridge that carried a medium tank might need assessment, reinforcement, or a different route for a Tiger. A crane, tractor, transporter, and maintenance detachment were not background details. They determined whether armor returned tomorrow. When Germany advanced, that tale had to keep pace. During retreat, a minor failure could become an abandoned tank. Enemy pressure compressed repair time, closed roads, and made towing slow vehicles a tactical risk rather than a workshop problem. The Tiger's protection improved survival in front. Its weight made survival after a breakdown far less certain. The same pattern continued inside production. A Tiger was not one factory turning steel into a finished weapon. Armor came from one firm, engines from Maybach, transmissions from Adler, guns and turrets from other specialized suppliers. Rail links, machining tolerances, and skilled labor connected them. A disruption anywhere could slow the complete vehicle. Then came the scale problem. Germany built 1,347 Tiger Emboise. More than 6,200 Panzer IIIs had been produced. Heavy battalions could deliver concentrated force, but never become the numerical backbone. Scarcity did not erase tactical value. It made every mechanical loss, delayed train, and missing spare proportionally more important. Heavy tank battalions could be shifted to threatened sectors, but movement consumed time, rail capacity, fuel, and planning. Once deployed, the tank needed petrol, 88mm ammunition, lubricants, track parts, tools, and trained mechanics behind it. Tunisia added dust and distance. German experience reports described engines there as too weak and sensitive, with wear accelerated. Captured Tiger 131 then became a prize, an intelligence object, and eventually a public symbol, precisely because Tigers were exceptional. The famous silhouette grew larger in public memory, while the ordinary trucks, workshops, and trains supporting it disappeared. Yet those ordinary machines decided how many Tigers were available, how far they moved, and whether damage became permanent. The battlefield would test that whole chain. The Allies did not answer the Tiger with one magic vehicle. They built overlapping ways to avoid its strongest contest. Anti-tank guns covered approaches. Infantry and engineers used mines. Artillery could damage tracks, bogies, and exposed support vehicles. Smoke and maneuver could shorten sight lines. Flanking fire attacked weaker aspects. Combined arms denied the clean long-range duel. None of this guaranteed safety. It changed the problem from penetrating the thickest plate to stopping the entire system. A mobility kill could be enough if recovery was impossible before withdrawal, artillery fire, or capture forced abandonment. A contemporary Allied digest translated Soviet instructions: hit the sprocket, idler, wheels, and tracks with armor-piercing or high-explosive fire. The aim was first to stop the tank, then attack its weaker aspects. Tiger 131 offers a concrete version. A shot jammed its turret mechanism, effectively preventing the tank from fighting. Its crew abandoned a largely intact intelligence prize. The strongest frontal plate had not solved a disabled weapon and exposed crew. But the balance cuts both ways. Late in the war, a Tiger ambushed the new American M26 named Fireball. An 88mm round penetrated the mantlet area and killed 2 crewmen. The Tiger's lethality was still horribly real. Then, reversing from return fire, the Tiger became entangled in rubble. Its crew abandoned it. Power met circumstance again. This is the distinction the legend often erases. A Tiger could win a duel and still lose operational value through breakdown, immobilization, recovery delay, fuel shortage, or simply absence from the decisive place. Tactical success was real. Operational effect depended on whether the next Tiger arrived, fired, survived, and returned again. Behind every comparison table were 5 men trusting that armor, engine, transmission, and recovery plan would all hold. A capable crew could exploit the Tiger brilliantly. It could not manufacture spare parts, clear bridges, or tow itself. Heavy battalions sometimes inflicted severe losses and stabilized local sectors. Those achievements belong in the record, not outside it. Yet fame grew through captured vehicles, official photography, soldiers' stories, and repeated encounters with an unmistakable silhouette. Rumor also collapsed different German heavy tanks into Tigers, enlarging the machine's psychological presence beyond confirmed vehicle counts. That psychological effect mattered to crews. Still cannot substitute for documented unit strength, readiness, or battlefield identification. King George's inspection of Tiger 131 shows how quickly the vehicle became more than hardware: trophy, intelligence, and propaganda. The image of one giant tank is memorable. A map of workshops, fuel columns, and unavailable vehicles is less cinematic. War, however, rewards the second picture: systems that can generate combat power repeatedly across distance, damage, and time. A Tiger abandoned in Italy expresses the limit plainly. Armor preserved a shape after the operational system had failed. Germany's industrial network kept building remarkable machines, but only 1,347 Tiger is entered a war of continental scale. Allied forces did not need every tank to beat a Tiger frontally. They needed routes, guns, repairs, and replacements. Over time, that wider capacity narrowed the situations in which a scarce heavy tank could turn local dominance into lasting advantage. The fair verdict is neither failure nor superweapon. The Tiger I was formidable when present, crewed, fueled, and working. Germany needed that effect reliably, in many places, at sustainable cost. The Tiger could not provide it.